Hello everyone, I'm Sebastian Y and welcome to Econometrics. In this video I'm going to show you how to use categorical variables in a multiple regression. I've got the cars dataset loaded up here. If we go into our data browser, we can see we have a variable called origin that has three possible values: Asia, Europe, and USA. We can see this is a string variable because all these values are in maroon as opposed to black like all the numbers. Another way to see all the values possible in a variable, we can use the tabulate or tab command and tab origin. We can see these three different possibilities. If we want to use these values in a regression, we're going to need to convert this variable into a set of dummy variables. I covered the basics of dummy variables in one of my previous videos on simple regression. There are two different ways we can go about this. I'm going to show you the long way first, and then I'll show you the shortcut. The first way we can do this is to manually create a dummy variable for each of our groups. To do this, I'll first generate a dummy variable for Asia. So I will gen Asian equals origin double equals and then in quotes Asia. Remember the use of the double equals for logic and the quotation marks to designate a string. We'll do the same thing to create a dummy variable for European cars. And then American cars. Whenever you make a dummy variable in Stata, it's always a good idea to check the data browser and just make sure that it worked properly. You can see here that I've got our Asian variable with ones for Asia origin, European with ones for the Europe origin, and American with ones for the USA origin, so this all looks good. It's important to remember that strings are case sensitive, and so that's a common cause of mistakes in dummy variables. We're now ready to run some regressions. Let's try running a regression of price on European and American. This is going to set Asian as the base group. Whenever we run one of these regressions, we always need to leave one of our dummies out as the base. And this is going to be the group that all the others are compared to. So what this model says is that an Asian car has an average price of $13,466. An American car will have an average price $2,837 higher than an Asian car, and a European car will have a price $13,377 higher than an Asian car. We always compare that back with the base. We can pick a different base if we want, so we could run the regression of price on Asian and European, leaving American as the base. And we can now see that the average price for American cars is $16,304, and we compared the other ones to that. Mathematically, these regressions are identical. If we scroll up a little bit, we can see that the root mean squared error is the exact same. The R squared is the exact same thing. Everything is the same except for the way that we interpret these coefficients. Predictions based off these two regressions will also be identical. What we do not want to do is include all three dummy variables in the regression. This is going to cause perfect collinearity, and Stata will automatically pick one of our variables to kick out of the regression. So we do not want to do that. The other way that we can do this is to use Stata's built-in functionality for what they call factor variables. The first thing we have to do is convert our string variable origin into a numerical variable. We're going to use encode to do that. So we're going to encode origin and then add an option. Remember, options always come after commas. Gen, and in parentheses, we're going to name our new variable. I usually call it something like origin code, but you can call it whatever you want. Let's pull up the data browser to check out our new variable. We can see we've got our variable origin code here that has all the same data as origin, but instead of maroon, it's in blue. Blue in the data browser means data labels. If we go over to the origin variable and click on the first value of Asia, we can see that Asia pops up in this bar up at the top, but if we click on Asia over here, we can see that it's actually a 1. If we click on the Europeans, we see there's a 2, and USA, there is a 3. What this means is that the origin code variable are actually the numbers 1, 2, and 3, with a label on top set to the original names. We're now ready to use this in a regression. Now what we don't want to do is put that new origin code variable straight in a regression. What I'm about to do is wrong. The reason for that is that I've now just treated this as a normal numerical variable, where Asia is 1, Europe is 2, America is 3, but those are just arbitrarily assigned based on alphabetical order. Europe is not actually 1 more than Asia, and the United States is not 1 more than Europe. That's nonsensical. So what we actually want to do here is put in reg price i.origin code. What this is going to do is temporarily create dummy variables for each of the categories just for this regression. You can see here that Stata has automatically picked group 1, which is Asia in our case, as the base group. And that's again because that came alphabetically first. If we look at the numbers here, they are the exact same coefficient estimates that we got back when we ran our first regression with the manually created dummy variables, with Asia as the base. In order to pull these coefficient estimates out as stored values, we need to know the underlying numbers that are in the variable origin code. So for example, I can pull out the European coefficient by displaying _b 2.origin code, because Europe is category number 2, and I could take the USA one out with 3.origin code. Now let's suppose we wanted to run this regression with a different base like USA instead of Asia. We can do this by running the regression again, but instead of I, we're going to put in B3.origin code. We put B and then the number of the group we want to be the base. Since US was group 3, we'll put B3. We can see now that we've got United States as the base group here. I.dot generally works fine if the order doesn't really matter, but sometimes it makes sense to pick a different one as the base, and this allows you to do that. In this video, we've covered the basics of how to use categorical data in regressions in Stata. If you have any questions, please let me know. Thanks for watching.